Hey guys, it's Miss Fendley. We are going to be finishing up the 7.3 notes, proving that a quadrilateral is a parallelogram. So a quadrilateral is a four-sided figure. So if you speak Spanish, you can hear that Latin base. Cuatro lados means four sides in Spanish. So cuatro lados, quadrilateral. Quadrilateral is a four-sided figure. And a parallelogram is a specific type of quadrilateral. So a parallelogram is a quadrilateral that follows some special rules. Quick review. The ways that we can prove that a quadrilateral is a parallelogram. First way is that the opposite sides are parallel. So if you look at this picture on the right, the left side and the right side both have one arrow, so you know that they are parallel. And remember, parallel means that the lines go in the same direction and they never cross. And then the top and the bottom each have two arrows, so they are parallel to each other. So here, the opposite sides are parallel to each other. The second way is to show that both pairs of opposite sides are congruent. Congruent means that two things are the same length. So if you look here, the left and the right both have a little tally on them. That tally tells us that they are the same length. So for example, if the left side is 5 units long, then the right side is also 5 units long. The top and the bottom each have two tallies. So the top and the bottom are congruent. So for example, let's say the top is 7, then the bottom would also be 7. Okay? The third way to prove a quadrilateral is a parallelogram is to show that both pairs of opposite angles are congruent. So what that means is that when we look here, the angles diagonally across from each other have the same number of congruence arcs. Those both have 2, and these each have 1. So the matching number of arcs tells us that the sides across from each other are congruent. So what that means, for example, is if this side was 150 degrees, then this angle would also be 150 degrees. If this angle is 30 degrees, then this angle would also be 30 degrees. Okay? The angles diagonally opposite each other are the same. The fourth way is to show that one pair of opposite sides are congruent and parallel. So here, and it can be either sides. They just chose the top and the bottom, but they could have marked the left and the right. The top and the bottom are both going in the same direction and don't so they're going in the same direction and they're the exact same length. Therefore, the shape is a parallelogram. And then the fifth way, and this is actually not all of them, but this is all we're going to do for today. The fifth way is to show that the diagonals bisect each other. And if you remember, the word bisect means to cut in half, two congruent halves. So the diagonal going this way cuts in half the diagonal going this way. And it works the same way. The green cuts the orange in half also. So however long this piece is, this is the same. That's what those little congruence marks tell us, which means that this is the midpoint of both diagonals. That point of intersection is the midpoint of both of the diagonals. Okay, let's look at applying those and using that to solve for missing sides and angles. So on the first example, it says, make the following quadrilateral parallelogram. Well, if this quadrilateral is a parallelogram, I know that opposite sides are congruent. Okay? Opposite sides are congruent. And here I have my opposite sides labeled, and I remember that congruent means the same, that they're the same length, okay? So the sides are going to be equal. So 3x plus 5 equals 5x minus 9, okay? And then it's just a matter of solving, okay? But I know that it's or to make it a parallelogram, I'm going to use the fact that the opposite sides are equal, okay? So I'm going to subtract 5x from both sides, right? 3x minus 5x is negative 2x. Bring down the plus 5. 5x minus 5x cancels, and I'm left with negative 9. Subtract 5 from both sides. Okay, so bring down the negative 2x. The 5 minus 5 cancels, equals negative 14. Divide both sides by negative 2, so x is 7. Okay, so if x is 7, then then this is a parallelogram, because that means that the sides are equal. And I can check that if I plug this back in. If I said 3 times 7 plus 5, well, 3 times 7 is 21. 21 plus 5 is 26. If I plugged it in here, 5 times 7 is 35. 35 minus 9 is 26. So it does check out that the opposite sides are the same when x equals 7. Okay. Example 6, and again, if I go too fast for you guys, feel free to pause the video at any point. Example 6, it's kind of hard to tell here, but I believe that this is what they're saying is 4x plus 2, and this is what they're labeling as 5x minus 6. For that theorem, I'm going to use the fifth one here, that the diagonals bisect each other. So if the diagonals bisect each other, they cut each other in half. And since I have this diagonal going through, it's going to be cutting the other diagonal into two congruent halves. Oops. Okay. So these are going to be the same length. Okay. So 4x plus 2 equals 5x minus 6. I'm going to move my x's to the right this time, so I'm going to subtract 4x from both sides. Those will cancel, bring down the 2. 5x minus 4x is 1x, which is just x, minus 6. Add 6 to both sides. So 2 plus 6 is 8, and on the right side, left with x. So x equals 8. So the two diagonals, or two halves of the diagonal, are the same when x equals 8. Okay. And I can double check that if I want. 4 times 8 is 32. 32 plus 2 is 34. And then check that on the bottom. 5 times 8 is 40. 40 minus 6 is 34. So the two diagonals, or two halves of the diagonals, are the same. They are congruent when x is 8. Okay. And then on the example 7, show it as a parallelogram, explain. So on this one, I'm going to use the fact that opposite sides are parallel. Okay. Opposite sides are parallel. Okay. When opposite sides are parallel, they have this, or when lines are parallel, parallel lines have the same slope, and slope is rise over run. Slope is rise over run. Okay, remember back from Algebra 1. So I'm going to find the slope of each of these four sides. So the slope from A to D, this here, starting on the left, going to the right, I go down 3, right 3, down 3, right 3. So the slope of AD is rise, or went down 3, run 3, -3 over 3 is -1. From B to C, I again go down 3, and since I went down, it's negative, and then right 3. Okay, so BC has a slope of -3 over 3 or -1. So right away, I know AD is parallel to BC, but I need both pairs of opposite sides to be congruent. Or excuse me, I do need them to be congruent, but I also need them to be parallel, and that's what I'm checking. Okay, so now I'm going to look at AB. To get from A to B, let's choose a different color. To get from A to B, I'm going to go up 2 and right 5. Up 2, right 5. So the slope of AB is rise over run, so 2/5. That can't reduce, okay? And then to get from D to C, I'm going to go up 2, right 5. Okay. So the slope of DC or CD is 2/5. Hey, those are the same, okay? So AB is parallel to DC. So since opposite sides are parallel, then it is a parallelogram, okay? And you can write that as a formal sentence. Opposite sides, I'm going to abbreviate a lot, are parallel. So ABCD is a parallelogram. Okay, and I could have used different theorems for this. I could have used to prove that this was a parallelogram. I could have, figured out that AD and BC were parallel using the slopes, and then I could have used the Pythagorean theorem to figure out how long they were, and then because they were both parallel and congruent, that would meet 4. Or I could have done the Pythagorean theorem on all 4 sides, and they would have been congruent, so that would have been using 2. So when it's on a graph like this, you kind of have some options of how do you prove that the parallelogram is congruent. I just went with, how do you prove that the quadrilateral is a parallelogram? That's what I meant to say. And I just went with the opposite sides are parallel, because I can do that really quick using the slope of, just counting the rise over the run. All right. Good luck, guys. If you have any questions, make sure you ask.